And for two-dimensional problems, I can draw this in a plane, but that's misleading. That's not what this geometrically really means. So what geometrically really means is that what we're assuming is that a dynamical system is smooth. So I have a manifold. It's 200 dimensional, but we can only imagine projection of three-dimensional blob onto a plane. So that's my manifold. It's some curved thing. Let's say surface of some potato. And at every point in the space, I have a velocity. Now, this was obtained as the first derivative of the flow. So this is actually lying in a tangent plane. What we are really doing is every point has this tangent plane. And now you have to think something that's hard to imagine. It's called a tangent bundle. You have a state space, it has points. At every point, there is a plane, which is a tangent plane. So that's called tangent bundle. And through every point, there goes a spaghetti. That's called a fiber. These guys on particular orbit, there's a bunch of tangent planes on a given fiber. So that's called fiber bundle. And that's how you have to think of these systems. It's a collection, infinite collection of infinitesimal motions. Each one of them is a linear space of same dimension as the original space. That's where velocity looks like. And you realize, you're doing general relativity, basically. That's how you think of all curved manifolds. If they're smooth, it means you can cover them with little charts, one for Alabama and one for Georgia, and they can maybe match on the Andes. But because manifold is spherical, they're not correct.
Professor, can I ask a clarifying question?
No, but okay, go ahead.
Okay, thank you. So I'm naive to a lot of this stuff, but I do have a question about tangent bundles. Is a tangent bundle associated with a point or a neighborhood of points?
A linearized neighborhood.
Okay.
So good. You're assuming smoothness. Mm-hmm. So that means when you're in Atlanta, you assume the world is flat. Mm-hmm. And as far as going to Dunwoody, it might be flat, but then things start happening. So you have a local chart, and that's what you always do on manifolds. It's very hard to do anything smarter.
Gotcha.
So you have, local. You have a book of maps which used to exist before Google Maps, and that's what Google also has. So they're local flat maps, and you just have to make sure that as you drive, they match up on the highway line. Cool. But
so yeah,
that's how you always chart manifolds.